Algebra students. Welcome to lesson 7.2, interior and exterior angles of a triangle. To begin with, we are on page 194, of course, going through 201, and we are going to first of all recall that the sum of the angles of a triangle is 180 degrees. And continuing, we also will recall that an equilateral triangle has three equal sides, noted by the two double tick marks, there, and also three equal angles, all equaling 60 degrees. So if a triangle is 180 and all angles are equal, 180 divided by 3 is 60. So always, equilateral triangles always have 60-degree measurements of their angles, noted by the single curves. We will also recall an isosceles triangle has exactly two equal sides, noted by those, and two equal base angles, which are opposite the vertical angle at the top. Sketch and write as you can. Pause and catch up if you need to, otherwise we will continue. And we will turn the page, and at the top of page 197, we will proceed with try it 4. I have a new tripod, so things are lining up a little wonky here. Oh my goodness. Okay, we will do our best. I think that's good. Okay, so in try it 4, please look at the figure. And you will notice that in that figure it says AB is equal to AC. Therefore, that makes triangle ABC isosceles. It also says DA is parallel to BC, setting up some corresponding angles for us, which we need to know to figure out what they want us to figure out. And they tell us now to find the measures of angles X, Y, Z within that triangle. So if you look at angle EAD, that measures 55 degrees. If you slide yourself down that transversal to angle ACB, which is angle Z that we need to find out, those are corresponding angles. Those two things are corresponding angles. Therefore, angle Z equals 55 degrees according to the rule of corresponding angles. Now, because triangle ABC is isosceles, angle Y is one of the base angles opposite of angle Z, so therefore angle Y is also 55 degrees because of the base angles of an isosceles triangle. Now we're all set up to find out angle X because, of course, the three angles total 180 because of the sum of the angles of a triangle. Therefore, X plus 55 and 55 is 180. X plus 110 is 180. Therefore, X equals 180 minus 110, which means angle X is 70 degrees. And there you have it. Proceeding to try it 5. Look at that figure. You do need to turn the page to the top of 198. Try it 5. You have two triangles. Triangle ABC is equilateral, and triangle CED is isosceles. It also tells us in the directions that figure BCD, in that figure BCD is a straight line, so all the angles on that line are going to equal 182. Then of course it tells us ABC is equilateral. It says CE is equal to ED, which makes that triangle isosceles, as we already have said, and it reminds us that angle CED at the top, because of that little square, is a right angle, therefore it equals 90 degrees. Now we are to find the measures of the angles X and Y. Okay, so the first thing we want to note that it's given, angle DEC is 90 degrees. So that's one of the angles. The base angles of an isosceles triangle is where we're going to go next to find angle X, because two of them, the angle X that is shown and then the opposite angle, will also call X because they will be equal because they're base angles. Plus 90 is going to be 180. Therefore, two of those X's is going to equal 90 degrees, because I would subtract 90 from 180 to even out the sides. Then dividing through by 2, we find angle X is 45 degrees. So we now have one of those angles. Now, if you go to the angle along that line, we don't need to find angle ACB. We already know that's worth 60 degrees because of the angles of an equilateral triangle. Now we have two of the angles on that line. Because it's a straight line, all the angles on a straight line are going to equal 180. So we're going to have angle Y, which is what we need to find yet, plus the 60 degrees of the equilateral triangle, and the 45 degrees that we found up there are going to total 180. So angle Y plus 105 is 180. I subtract 105 from 180. I found out angle Y is 75 degrees. Okay. We have another little bit of vocabulary to work out here. Boy, this is at a weird spot. Okay, I think, okay. All right, let's try this. First of all, the properties, and then I'm gonna just slide this. I gotta make this a little bit smaller. My apologies. This is a new tripod. It's not exact. Oh, there. That's gonna be a little better. We'll try it. And it wobbles. Sorry, so sorry. Anyway, continuing. The property that we're going to record at this point is that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two opposite interior angles of the triangle. And we're going to call that rule the exterior angle of a triangle. So if you'll notice here, ABC is the triangle. ACD is the exterior angle of that triangle. And that's made by extending the base and using one side of the existing triangle. And that makes the exterior triangle. Now, the property says this angle is worth A and B added together because they are the opposite interior angles of that triangle. So therefore, angle X is going to equal angle A plus angle B, according to the property of exterior angle of a triangle. So let's move on to try it 6 at the top of 199. Look at that figure. You do see a triangle with an exterior. It's kind of situated a little differently, but there it is. It says in the figure BCD is a straight line. So let's find the measure of that exterior angle, ACD. So basically all we know is that ACD is an exterior angle. And we're going to add the opposite measures of those opposite angles, which are 33 and 118 because of the law, the property. Added together, we find out that the angle they want us to find, ACD, is worth 151 degrees. Moving right along to try it 7, it says in this figure, now look at that, you have a big triangle and a little triangle in there, and they're both sitting on that straight line because the directions say in the figure ABCD is a straight line and BE is parallel to CF. And that's really key. That's very key because what that does is angle try it 7, angle DCF, which is that exterior angle, is going to also be equal to angle CBE. And we can say that because it's corresponding angles because of those two parallel lines, okay? So that means the opposite angles of that smaller triangle, 36 and 31, total 67, which is the exterior angle of the little triangle, which is also going to work for the exterior angle of the big triangle because of those parallel lines, so 67 degrees. Okay, now we can go on to try it 8, the top of the next page. And we have that figure that sort of looks like an unfinished 5-pointed star. In that figure, ABC, CDE, AFD, and BFE are all straight lines. So it's all made up of straight lines. And we need to find the measurement of CAD. Then you have some angles that are given measurements already. So here we go. Angle FDC is the exterior angle of a triangle, FDC. I'm kind of getting mixed up. Yep, FDC, I was looking wrong. So that is the exterior angle of that tiniest triangle. So we just add the two angles given, 61 and 39, which is 100. And now angle CAD, we can just use that exterior angle we found here to find the sum of the angles of that larger triangle that they have, triangles ACD, but that angle would be 100. And this is a different way of finding it. You just subtract the angles that you know. So 100 minus the 52 that's given, and then minus the 100 that we found up there would equal 28 degrees. So there's two ways of doing the sum of the angles. Some people like to add and then subtract. Some people just like to subtract twice. It doesn't matter which way you do it. So it all ends up okay. Now, top of the next page, 201, is try it 9, and that's what we'll end with. Okay, I think I'm in the frame. Yep. So we got that funny looking figure, and I actually had to reproduce it. Sometimes you do need to draw and sketch out the figures because, as you can see, I needed to add a line to help things because they want us to try to find ADC. So that's that exterior angle, but I needed that dotted line to help me do it. So we first extend BD to E. That's the first thing that we need to do. And we need to find this whole measure here. All right. So the first thing we note is that angle ADE is equal to 30 degrees plus angle ABD. And we have to do it that way because it's half of this angle, or it's part of that angle anyway. So, and that's because of the exterior angle of a triangle. So then angle CDE, so we have this part being the exterior angle of this plus half of that, and then we have angle CDE, the other exterior angle. It's going to be equal to 36 plus the remaining part of that 55 degrees. So we just write it like that, okay? Therefore, angle ADE is going to be equal to, ADC, which is what we need, is going to be equal to ADE plus CDE. So eventually that's what's going to happen. Therefore, we're going to just add everything all together. So 30 degrees plus 36 degrees plus these two parts, which in reality just always total 55 degrees. So we have 30 plus 36 plus 55 is 121. Don't even have to figure out what part is what. We just have to add it in there. Okay, there you have it. I will be giving you your assignment when you get into class. Today is going to be a lot of really just understanding what you're looking at. If you have any questions about any part of this as you go along, please be sure to ask. Take your time, look carefully, do good math. Thank you.